Sketch the curve with the given vector equation. Indicate with an arrow the direction which t increases. So we have our first vector function r of t equals to, we have two components, sine a of t, sine a times t, and then comma t. So this is x, and then this is y. The parametric equation is x equals to the sine, y is equals to t. So we have y equals to t. So that means we can plug in the, we can change the t to a y, and then we write the x function. So x is equals to sine of a y, and then what is the period? So the period, you back to a trigonometry, you take 2y divided by the number in front of y, so which is 8. 1 period is equals to pi over 4. And then, so this is x equals to sine of y, right? So the parabola, I mean not the parabola, the sine function will look like this. So we, instead of going this way, it will just go this way. So between 1 and -1, so that is 1 period, and then you extend, and then you extend that a little bit because the function will just keep on moving. And then the arrow, so as t increases, you can try different t values, like t equals to 0, t equals to 1, and then t, and then you can just try different t value, and then you will see that it will just go this way. And then on the other side, you go half period and then a full period, and then you extend it a little bit. It will just go this way. All right, so that is the first question. And then the next question, we have a vector function, r of t equals to t, 9 minus t, 2t, so 3 components. The parametric equation, x equals to that, y equals to that, and then z equals to 2t. Now, we have to start at t equals to 0. So we match the color first. So when t is equals to 0, what point, where is the point when t is equals to 0? So the point is at when x is t equals to 0. So all you have to do is you plug in t equals to 0. So the x value is 0, and then 9 minus 0, and then 2 times 0. And then when t is equals to 1, so where is the point? T is x is equals to 1, 9 minus 1 is 8, and then 2 times 1 is equals to 2. So we use 2 points to get a line. So we use 2 points to get a line, which is what you see in the picture below. So I have a 3-dimensional picture in case my handwriting is not good. And then we can find the directional vector. So from point 1 to point 2, what is the direction? So here is direction vector. So that is what? That is the point 2 minus point 1, 1 minus 0, and then 8 minus 9, and then 2 minus 0. So what is this vector? This vector is 1, -1, and then 2. All right. So we have our x, y, and z. So where is the first point? The first point is when x and z, they are both z equals to 0, and then we have a 9 over here. So this one is y equals to 9, and then we have a point over here, just like what you see on the picture. And then the next one, wow, this is hard to plot. X equals to 1, y equals to 8, z equals to 2. So x equals to 1, y equals to 8. So here, x is equals to 1, and then you go on y equals to 8, and then z equals to 2. You will just have to go up 2 units. All right, so the point is right here. Again, x is equals to 1, y is equals to 8, and then z is equals to 2, like right there. So you just plot a point right over here, and then you connect the points. You connect them from point 1 to point 2, and then you just shoot a vector to this way. And then what else? To this way. And then this indicates the 1, -1, 2. So that is a vector that indicates our direction. So this indicates our direction. If you only have one point, you don't know where to go, right? So you need to know the first point and the second point. You connect the first and the second point using an arrow. You know that the vector is going that way. So in case my handwriting is not good, I have a picture in there for you. The red point is point z, t equals to 0. The orange point is when t is equals to 1. All right, so moving on to the next problem. The next problem we have another vector function, t square I plus t to the 4th j plus t to the 6k, and then three functions x, y, and z. So x is t square, y is the 4th power, and then z is the 6th power. So what happened when t is not equal to 0? So when t is not equal to 0, let's complete the sentence. When t is not equal to 0, so both x, y, and z, they are all greater than 0. So x, y, and z, they are all greater than 0. So how about when t is equals to 0? When t is equals to 0, and then we have a point, just plug in 0 to the x, y, and z. So this is, they are all 2nd power, 4th power, 6th power, right? Then you start at the origin. And then the curve in the first octant. In the first octant, we are talking about three-dimensional. We are not using like the 2nd quadrant, the 4th quadrant, the 3rd quadrant. We are using octants. The first octants where x, y, z are all positive, x, y, and z are all positive, and then the t square, I am going to change that. So the t to the 4th power, I'm going to change that to a square. That is equals to t to the 4th power, and then x is equals to t square, and then that implies that x equals to x square equals to t to the 4th power, which is equals to y. And then as a result, we have y equals to x square, and then also z is equals to t to the 6th, which is t square raised to the 3rd power. So z is equals to, and then also here, the t square is equals to x square. So x is equals to t square. Therefore, z is equals to x to the 3rd power. So we have y equals to x squared, z equals to x to the 3rd power, and then at the very beginning, x is equals to t squared. So we have x is yeah, actually we don't need that anymore. So we have that, and then when t is equals to 1, so the vector function r of 1 that is equals to x is t squared, so that is a 1, and then y is a 1, and then z is a 1. So we are basically writing the y and expressing the y and z in terms of x. So these are all 1, and then now we are ready to sketch the graph. So 1, 1, 1, and then in the three-dimensional picture, the point is right over here, right? So this is where 1, 1, 1 is. So here is where the 1, 1, 1 is. So first of all, we sketch our first graph. So from the origin, so from 0.00 to 1, 1, 1, and then the graph looks like that. I know it's very hard to see. It looks like that. So that is the first graph. And then how about y equals to x squared? Y equals to x squared. Y equals to x squared. Let's use a different color. Y equals to x squared is like right here. So y equals to x squared. The parabola looks like that. So that one is y equals to x squared. And then how about the last one? The z equals to x to the 3rd. So z equals to x to the 3rd. Let's change that to a different color. Right here, that is z equals to when a z is equals to 1, like right here. So this is a z equals to x to the 3rd, and then that one, the orange one. So this one is z equals to t to the 6th degree, and then it's increased very fast due to the 6th power. Alright, so that is the end of this problem, and that is also the end of this video. If you like the way I explain, sketch the curve with the given vector equation, indicate with an arrow that the direction which t increases. If this is something that you would like to see in the future, give this video a thumbs up, give my channel a subscribe. As always, I will meet you all in the next video. Signing out.